In this video, we're going to continue to look at lipids, or rather hydrophobic molecules inside your body. And so we're going to start with steroids this time, and they are found in eukaryotes, and they're derivatives of cyclopentoperhydrophenanthine. I think I got that right. Cholesterol is your most abundant steroid, but all steroids, for the most part, have this four-ring structure. Now, cholesterol, shown here, you have a little OH and you get another aliphatic tail. 30 to 40% of the plasma membrane lipids will have cholesterol in them. And they're esterified to form these esters. Now, the reason that you have cholesterol, and we'll talk about this in a later video as well, is that it helps to modulate how fluid your membrane is. In plants, they don't really have cholesterol, but they have other sterols that do the same thing as cholesterol. Now, cholesterol is a precursor to make many other steroid hormones. One class is the glucocorticoids, or also known as cortisol, and here's glucocorticoid right there, and they will affect many different processes, such as carbohydrate, protein, lipid metabolism, inflammatory reactions, and stress reactions is when you can also release them as well. Aldosterone and mineral allocorticoids, these help regulate salt and water excretions by your kidneys. You have your androgens and your estrogens, which is sexual development, so testosterone and estrogen or estradiol are your most representative case, and these are usually synthesized by the cortex of your adrenal gland. So you can see that your steroids can affect a lot of things in your body, a lot of different processes. So we're going to continue with steroid derivatives now, and we're going to look at a lot of vitamins, and we're going to start with vitamin D, which is a hormone. And you have two different main types of vitamin D. You have D2 and D3. Here's what they look like, and the difference is what the R group is. So X is vitamin D3, Y is vitamin D2. And then so D2 we get through UV radiation, actually both vitamins. So here we can see our process. We need that UV radiation to open up the ring between carbon 9 and 10, and then after you do that, spontaneously form this double bond. So that is how we activate vitamin D. But if you get 15 minutes of sun 3 days a week, you have enough UV radiation for vitamin D. Now, vitamin D and 3 themselves are inactive, so you need to add enzymatic hydroxylation to make them the active form. And what vitamin D does is that it helps promote how much calcium that you absorb through your diet. So you really want vitamin D, and that's why they have it in milk. That's why they say it strengthens your bones. Vitamin D helps you absorb any calcium that you eat in your food. Now let's talk about isoprenoids, and these lipids are not structural, and they're called isoprenoids because they're built from this 5-carbon precursor called isoprene. Now, even though they're not part of the structural membrane, they are soluble in the lipid bilayer because you can see they're very hydrophobic, so they can go in there. And your most important isoprenoids is coenzyme Q or ubiquinone. This is a very important molecule in oxidative phosphorylation. It will carry electrons and hydrogens for you, part of the proton pump, and we'll cover that in Biochem 2 when we talk about how to get energy from glucose or glucose metabolism. So we're going to look at a bunch of vitamins now. So let's look at vitamin A, also called retinol. This is derived from plant products such as beta-carotene. Beta-carotene is found from carrots. So this is why people think that if you eat carrots, your vision will increase, which is not actually true, but you can see why that first started. Now, what vitamin A does is that it will function in the eye's photoreceptor at low light. Basically, in low light, when you see a light signal, that will cause vitamin A to react, and we have that as a chemical signal to say, oh, there's light around. And if you don't have vitamin A, you can become blind because you cannot detect light photons without vitamin A. Vitamin K is another vitamin that is part of blood clotting. And these are actually synthesized by plants, funny enough. But half of our requirement for vitamin K comes from our own gut bacteria. So although we don't make vitamin K, we get half of it from what's in our gut already, the other half through plants. And like I said, this is part of blood clotting, and if you don't have enough vitamin K, you can have excess bleeding. Vitamin E, another vitamin, is highly hydrophobic, and so this will be found in the cell membrane again. And this is an antioxidant. We talked about antioxidants in the last video, but this is an antioxidant for the membrane, lipids, and proteins. This will help absorb any free radical oxygen so they don't harm your cell membrane lipids and they don't harm your cell membrane proteins. The most common form of vitamin E is alpha tocopherol, shown here. And if you do not have enough vitamin E, you have a lot of nonspecific symptoms. So it's very hard to diagnose deficiency in vitamin E because that can have a variety of symptoms. However, if you take too much vitamin E, then you might have an increased risk of cancer. The last type of molecule we're going to talk about is the eicosanoids, which are a less common lipid that are from your prostaglandins. But they're very important. They act in low concentrations, and they're involved in pain, fever, blood pressure, blood coagulation, and reproduction. And when you take aspirin, what you're actually doing is you're stopping the production of a bunch of these molecules. So that's why aspirin reduces pain and fever and blood pressure and blood coagulation, because you're cutting off the synthesis of all these molecules which are involved in that. And these molecules actually act locally, that is, we don't transmit them in the blood, and as soon as we make them, after a couple seconds or minutes, we will destroy them. So we release them for pain and fever, and as soon as they're released, they're destroyed again. That's it for this video. I will see you in the next one.